Hey everyone, today is Wednesday, September 29th, 2021. Thanks for joining the SMI community call. This call happens every other week. We're going to kickstart this call with some announcements. Then we have some discussion items, and we have an exciting demo with Flagger and some recent SMI features that have been included in the project and OSM. This will be like kind of an example of how you can use Flagger and SMI. So I'm really excited about that. And if you're joining us, please go ahead and put your name and company information on the meeting minutes doc, which has been pasted in the chat. So, all right, everyone. Bridget, you want to take the announcement section?
Sure, absolutely. Thank you, Michelle. So 2 weeks from today would be the SMI community meeting, but as per usual for CNCF related events, we are canceling that community meeting due to KubeCon on October 13th. Instead, we will be able to have you join the office hours on October 14th. So we put a link in the notes. It is on the community.cncf.io page. And this is SMI office hours associated with KubeCon. So join RSVP on Bevy, and then you'll get a link to join the interactive office hours, which I am given to understand that our very own Michelle will be leading.
Yep, so feel free to join if you have beginner questions, if you're just wondering why a particular part of the spec is the way it is. I'm happy to help answer questions. We can debug things if you feel like this is really your time. We can just have a chat, get to know each other. So just join, and we will, get to know each other. That'll be good. All right, thanks, Bridget, for the announcements. In terms of discussion items, we just have like some status updates, and then we'll just dive right into the demo. So the first one is please review PRs. If you are a maintainer, we definitely need maintainers to review PRs, but we also need non-maintainers and just people who are interested in the community to chime in and give us their opinion on how the spec should grow and what is confusing, what's not, and what's going to add more clarity. So any and all opinions are welcome. We do have a few PRs in flight right now. Our very own Johnson has given us some clarity around traffic splitting, and in one PR, and another one is there to rename traffic target to traffic access, which is a little bit more clear in terms of like what that API is for. So I'm excited about those, but please chime in with your opinions. We also had a few other smaller PRs in the issue queue. I'm going to spend some time triaging issues this week. So if you have open issues, feel free to ping me. And then I'm also going to take some time to update the SDK with status fields on the APIs. They are missing status fields, and I don't think that there's any historical reason why we shouldn't have those fields there. And adding those to the APIs will allow implementations to update the status fields. And so we can talk more about that through GitHub or Slack if you're interested, but that's kind of like what my focus is going to be for the next few weeks. Does anybody else have any items they want to discuss? Any questions, any concerns?
Nothing from me.
Okay, cool. Then let's go ahead and move into the demo. Johnson, I'll let you take it away.
Hello there. Yeah, so my name is Johnson. I'm a dev in the same team as Michelle. And I basically, I think a month ago, I worked on integrating Flagger with Open Service Mesh. So Flagger is a Cloud Native Computing Foundation project that leverages Open Service Mesh, that can leverage Open Service Mesh. In particular, it can leverage OSM's SMI traffic split policies to implement progressive traffic shifting. So basically, let me share my screen. How do I share my screen?
Should be the green button at the bottom. Okay.
Okay. Yeah. So basically, let's say you've got an application that you're interested. Let's say suppose you got a customer application. Let's say the app primary, and you want to roll out some changes, like let's say bump up the image version or make some changes to the app's deployment spec, deployment YAML. Well, so let's say suppose you don't want to shift all of the traffic over to the newly changed image or the newly changed deployment spec. Well, here's what so Flagger's use case is that it can slowly shift over traffic, by leveraging OSM's traffic split mechanism to slowly shift over traffic split from your primary instance to your canary instance. So the newly applied image, the newly updated pods, and it'll monitor Envoy metrics, let's say HTTP success rate, HTTP latency, or any other custom metric that you define. And based on success criteria, it'll slowly shift more and more traffic over to the canary instance until it reaches 100%, at which point the progressive upgrade is considered successful. And you now have a V2 of your app that's been successfully rolled over. So, and upgraded. So here's the demo. I'm not so sure if you guys can see. So I've created a new cluster, and I went ahead and did this, a new client cluster, and installed OSM in the cluster with Prometheus and permissive traffic policy installed, enabled. So as you can see, kubectl. This cluster is completely new. It's a brand new cluster with a newly installed OSM control plane in the OSM system. So what I'm going to be demoing is I'll be installing the Flagger control plane into the cluster, create a demo application, an app, and then instruct Flagger to monitor for changes in the application. So the Flagger controller will monitor for changes in the application. And what I will then do is I will update the image version of the application, bump it up by one version, and Flagger will set this whole thing up by itself. It will notice that the application app spec has changed, so it'll create a traffic split, an SMI traffic split, very obvious use case of SMI, and then set this up. It'll spin up the new pod with the updated version and slowly shift things over. So I've gone ahead and installed OSM, as you've seen. Next, I'll install Flagger in the cluster. So I could install that using kubectl, customize, or using Helm. So I'll go ahead and install Flagger into the cluster. As you can see, we now have the Flagger controller inside the cluster, specifically in the OSM namespace. And now it's ready. Next step is we're going to create a namespace called test. So test is where the application will live in, the application that we're interested to monitor for upgrades. So this is where the customer application, customer namespace is. So we're going to create a namespace, add the namespace to OSM, and enable monitoring in that namespace. I'll increase this a bit. Next, we're going to create the application itself. This one. We're going to create the application itself in that test namespace. As you can see, we now have the application, the demo application in the test namespace. And we're going to be creating a load testing service to generate traffic for the purposes of our demo. So this load tester will generate fake traffic fix successful and failed traffic in the pod in the customer application pod info, for the purposes of the demo. As you can see, the load tester is right over there. And it might be a good idea at this point to look at the services that we have in our cluster. So at this point, we do not have any services yet that we are interested in. So the next step that we're gonna do is we're gonna create a. So basically, this is the meat of the demo, basically. So we're leveraging Flagger's custom resource definition, canary CRD, and what this CRD provides us is for a mechanism to instruct Flagger. So basically, we're gonna be instructing Flagger, hey, Flagger, please monitor for changes in the pod info deployment. So that pod info deployment, please monitor for changes in that deployment spec. So this one basically, monitor for changes, and basically every time you every time you want to bump up, progressively shift traffic over, do it every 30 seconds. You can only tolerate five metrics check failures before you roll back, cancel the progressive traffic shifting. Every time you increase the percentage from the old instance to the new instance, shifted by 5%, please look at these metrics, success rate and request duration. And yeah, so basically as this is happening, Flagger will look at the request success rate and request duration of the application. And if any of these drop below a certain threshold 5 or more times, the whole thing is rolled back. And in case you guys are curious where the request success rate and request duration metrics come from, they actually come from OSM's own Envoy metrics. So request duration total and request duration milliseconds. So Flagger leverages some of OSM's metrics to determine the success or failure of the new deployment. So I'm going to go ahead and kubectl apply this set of instructions. So basically, this instructs. So basically, Flagger has now acknowledged and received the instructions to monitor for changes in the pod info deployment. Are you guys following along? I'll pause here for in case you guys have any questions.
So far, so good.
Okay, cool. So now what I'm gonna do is so as of now, you guys can see there are no traffic splits. So look, there are no traffic splits within the cluster. And if you get that traffic split in that test namespace, it's all going to 100% primary. So there's no canary instance because we have not, we have not made changes to the pod info deployment spec. So no changes. So everything is still 100% in primary. And if you guys look at if we get the canaries in all namespaces, you can see that it's initialized. Basically, this means Flagger has acknowledged receipt of our instructions. It is just waiting. And
so wait, does initialized mean ready? Is that different from running?
Oh, what this means
I'm confusing
is that,
initializing with pod initializing, I think.
So initialized here in Flagger's terminology means that it is now ready to monitor for changes in the pod info deployment app. So once you see initialized, if you bump, if you change the image version in the pod info deployment, or if you do other changes to the deployment YAML, Flagger will go, Flagger has visibility and is will be made aware of these changes, and it'll do the progressive traffic shifting using traffic splits.
Okay, that makes sense.
Yeah. So basically, if we have a look at the pods that we have, see, we have the load tester and the pod info pod. And if we look at the services, we have a primary service and we have a cannery service. Now, if we look at what using the cannery services selector, we can see that there are actually no applications. There are no pods as of now that is backing the cannery service, because obviously we have not made any changes. There's no upgrade in progress. Now, if we look at the primary instance, which is the main instance of our application, oops, pod info dash, we can see that there are pods backing the primary instance. So this is the default scenario. Nothing's there are still no image upgrades. Now we're going to trigger an upgrade. So as you can see in this command, what we're doing is we're going to be changing the pod info deployment. Okay, so as of now, the image version in the pod info deployment is 3.1.0. We're going to be changing the deployment spec to 3.1.1, bumping up the version. Now, if you look at what Flagger says, it says, "Hey, progressing. I was made aware of changes to the pod info deployment." Now, if you look at it, it says, so a few minutes ago, it was finished. It began monitoring. As you can see, initialization done. It began monitoring for changes. It's looping. It began monitoring for changes in the pod info deployment. It says, "Hey, you've got new revision detected. I will scale up cannery, I'll scale up a cannery instances to do this thing." So 3.1.0 is this one. 3.1.1, the new application, the new version will be here. We can watch this. So if you look at the end, so as you can see, it says, "Hey, I'm starting cannery analysis and I've progressed the weight to 5. If we go here and check the SMI traffic split policy, you can see that we still have the traffic split over there. And if we look into the YAML config of that traffic split, we now have 10. So it's slowly progressing things over. See? Because, the metrics checks are successful. And if we look at the services, we have the cannery service and primary service. If we look at the primary service, we can see that we still have the pods over there. But if you look at the cannery service, which previously did not have any backing pods, now you've got the primary service, you've got the cannery service receiving traffic as well, a portion of the traffic. Everything's going well. This will take some time. The pace in which the upgrade happens, the percentage that this is stepped through depends on the set of instructions that you've given them. You've given to Flagger. In this case, every 30 seconds, it's going to step the weight by 5%, as long as 99% of HTTP requests are successful. Not, basically, if they're not 500, I've defined it to be non-5xx. And also, as long as the P99 of HTTP requests is less than half a second. As long as that's happening, then, basically this will happen. It'll continue stepping through. Eventually, this is going to take a few minutes. Eventually, this will succeed to 100. 100% of the traffic will go to cannery. And what's going to happen at that point is primary will be deleted. Cannery will then be renamed to primary. So, the progressive traffic shifting is complete. And This is going to take about 5 to 10 minutes, which obviously we don't have time. We're going to run out. But this is basically a very cool demo and real world application of SMI, in action. In fact, we're not the only service mesh that utilizes SMI for Flagger progressive delivery. Linkerd as well leverages SMI to have progressive traffic shifting, with Flagger. And this is a very powerful tool because it can be used for automated canary promotion, and if you encounter, for instance, a lot of HTTP 500 errors or a lot of latency, then Flagger, through the use of Envoy metrics as well as SMI traffic split, will realize that, hey, something has gone wrong with the upgrade, and I'm going to roll everything back. I'm not going to go proceed with version 2. I'm going to stick with V1. I'm not going to go to V2 because Prometheus metrics scraped from Envoy, as well as Prometheus metrics, and is showing that there's a lot of failures. They've reached the threshold, so I'm going to roll back the SMI traffic split. Yeah, that's pretty much it for my demo. You guys have any questions?
Johnson, that was really cool. I have many questions, but I'll start with just how, when you mentioned the Prometheus metrics, and I started thinking, oh, maybe people could put in some kind of alerting hooks or something to like flash big red lights saying, just so you know, we're still on V1 because your deployment for the new version failed. Like, how does this fit in with, monitoring, alerting, et cetera?
So it can scrape any Prometheus queries. You can use built-ins like request success rate and request duration. All service meshes that are supported with Flagger implement these. But in case you want to have additional metrics, then you can write your own PromQL metrics. So basically anything that's PromQL compliant, anything that's PromQL compliant, you can put it into Flagger's metric template CRD. So this metric template, this CRD from Flagger itself is basically an instruction set to the Flagger controller telling them that, hey, instead of monitoring something else, I want you to be made aware of a new Prometheus metric you gotta watch out for, and it's based on this PromQL definition. You can have webhooks. Pre-rollout webhooks, post-rollout webhooks, posting or getting posting and getting information to and from various endpoints. So while it's in progress, you could have webhooks. You could have webhooks for confirming traffic increases, webhooks before the rollout, and you could have webhooks after the rollout, which is very useful for alerting as well. If you want alerting, if you want different on endpoints, like Slack and Teams to be notified of your progressive delivery, then you have it here all in the docs. Because a realistic scenario isn't a realistic real world scenario, it's probably likely that they're going to run this progressive traffic shifting over maybe a weekend or a few days, and you've got millions of customers. They're not going to do it over 5 or 10 minutes like what our demo is. So it'll be useful to have webhooks to alert you along each stage of the way, manual gating, and Teams or Slack notification.
Awesome. Thank you so much.
Yeah, like for instance, if you want to have a bit of fine-grained control, maybe you want to do automated progressive traffic shifting until 75%. But then when it's 75%, you want Flagger to ping this webhook, so that you have so that some of your script can run and manually, approve, 75% onwards, something like that.
Hey, Johnson.
Yeah.
Awesome demo. Did you what did you do to configure configure Flagger to work with OSM/SMI? What were the knobs you really needed to turn, and kind of where do you configure that?
So basically in the Flagger flux cd/flagger, in the Flagger code base, there is so I implemented it in one of my PRs quite a while back. And basically there's an SMI router here within the so basically I had to work with the maintainer of Flagger, Stefan, who is also one of the maintainers of SMI. So we worked together to so some of this stuff was already in place. There was already an SMI v1 alpha 2 v1 alpha 3 router, and I had to so basically I leveraged the pre-existing SMI routers to create which are, so basically this is part of the Flagger controller. The Flagger controller would leverage this these SMI routers to create a traffic split. I had to contribute to Flagger because there were some bugs in how they there were some bugs in the SMI router, but once that was resolved, thanks to the kind guidance of Stefan, the rest of this PR was very fast. Yeah, so basically this functionality mainly utilizes the inbuilt custom SMI router that already existed in the code base.
Very cool. And
Yeah.
so like basically this is like a flag you'd have to turn on when you deploy Flagger, right? Like you'd have to say this is that we're going to use we have an OSM provider.
Correct. So you got to say, you can apply the defaults, or if you want to have more fine-grained control, you got to, you can say, hey, I want it, I want the Flagger controller to be installed in this namespace, and we're going to use the namespace OSM. So I mean, we're going to use the OSM provider, the mesh OSM provider. So as long as it's set to this one, we're going to be automatically using SMI v1 alpha 2 traffic split.
Gotcha. So like there's not like an SMI provider, it's an OSM provider or a Linkerd provider, right?
So there is a Linkerd provider, there is an OSM provider, but there's also an SMI v1 alpha 2 and v1 alpha 3 provider. You could specify all of them. Yeah.
Very cool. Very cool.
Yeah, like one of the ones over here, it's basically you could specify the SMI v1 alpha 3 provider, v1 alpha 2 provider, and it'll do all that. So alpha 2 or alpha 3 or Linkerd or OSM.
Very cool. Okay, cool. Thanks. That answers my question. And actually, I think we are at time. So if anybody has questions for Johnson, please ask them in the Slack channel. And are there any volunteers to be moderator for a month from now? We can also ask in Slack because it's a month from now. So I don't know if people's
who knows what's happening in a month, but I'm sure I'll help. Yeah.
Okay, sounds good. Same here. We'll figure that out in Slack. Thanks everyone for joining, and thank you again, Johnson, for that awesome demo. Have a great day.